Hi everyone, welcome to PrestoCon. Today I'm going to talk about a self-serve data architecture, define what the term means, some trends that we have observed, and also how to construct solutions that stand the test of time as a data platform evolves. Before I begin, a little bit about myself and Alluxio. I am Adit Madan. I'm a senior product manager at Alluxio, the company behind the open source project with the same name. I'm also a member of the project management committee for the Alluxio open source project. The Alluxio open source project itself is widely adopted by the community. We have a large and vibrant active community with members like you, with more than 1,000 contributors on GitHub. We're also rated one of the top 10 Java-based open source projects, and we have a lot of followers on GitHub and the likes. The platform provided by Alluxio is in use by thousands of users across the community and large enterprises. On this screen, you can see that especially in the financial services sector, the telecommunications and media sector, the Presto and Alluxio stack is widely adopted. The Presto and Alluxio stack is also trusted by the largest technology companies in the world. In the rest of the conference, you'll also hear about some of the innovative collaboration that is happening between the two open source communities. So, what does the term self-serve data architecture actually mean, and why is it important? First, the evolution of a data platform, if it does not need regular changes, that just means that the platform is now self-serve. For example, when you have a new data storage system that's added to the platform, or you have a new compute engine that is introduced, or for example, if a new team needs access to the same piece of data which is managed by a separate team, if your platform is able to handle all these forms of evolution, then you could say that your platform is self-serve. At the same time, self-serve does not come for free. The other aspect of self-serve is that there needs to be sufficient isolation between different business units or teams so that one business unit does not step on the other. So this could mean that, for example, when you have data access being managed by one team and a new team is introduced, the new team has absolutely no impact on the existing usage of the shared data infrastructure. The combination of the above two offers agility, which often is more important than the total cost of infrastructure. But I'll talk about both agility and total cost of ownership in the rest of the talk. Even though the trends that I'm going to introduce may seem familiar, solutions to these can oftentimes end up being more complex than they need to be. So I'm going to suggest a few architectural patterns to design simple solutions. The first trend is that data is shared in many different ways. First, we have a large amount of specialized compute engines, each which is better suited for a specific task. What this means is that there is a need to share data between all of these different engines. Presto for interactive queries and anything that may precede it for, let's say, ETL or batch processing. Then data is also shared between different platforms or between teams. For example, there could be a team A, which is the producer of a data, which is a collection of different operational data, which is then consumed by multiple different business units. Alluxio provides an abstraction layer across clouds and private data centers, which allows for this seamless sharing of data between Presto and other compute engines on top, regardless of the location of the data. So at the bottom, you can see that the location of the data could be across a single cloud or multiple different storage providers, but Presto and other compute engines would be able to share the data using the platform that Alluxio provides. For such a platform, Intel Optane persistent memory provides a great storage media for caching and data management. The second trend is that data is always owned by someone, and processing of the data in place makes this simple. The concept of governance, in which the owner of a data lake would like to enforce strict policies about the consumption of data, and to add to the complexity of this process is not static. So not just governance, but also at the same time, data copies makes this whole process even more complex because data copies are error prone and have high total cost of ownership. So it might feel fairly straightforward to us that the solution is not to make copies, but what about performance if we don't move the data? A single abstraction layer which takes care of both governance and compliance, but also performance and movement of data across ownership domains simplifies this architecture. In this architecture, you can see that Presto using the Alluxio layer for access to data regardless of the location, really simplifies our architecture. The previous picture can be broken down into a few simple cases. Uh, you can see it could be either all within a single cloud or a single data center, or it could be shared across multiple data centers or a hybrid cloud. In all of these cases, the separation of the consumer of the data from the producer of the data is enabled by an abstraction layer, which provides more than a simple cache. Advanced preloading capabilities, asynchronous write capabilities guarantee SLAs, even though the separation of data from compute exists across different domains. Now, the third trend is really all about elasticity. We all know that elasticity is a trend that is being employed to optimize the total cost of ownership. Now, by elasticity, I mean these compute instances, which could be running on expensive GPU instances or really powerful CPU instances with Presto. These instances can be spun up and down based on periods in which the compute is not being used or applications are not being run. To optimize TCO, elasticity is the key, but this should not come at the expense of the user experience. And by user experience, what I mean is that not just the user experience should remain exactly the same as it was before, including execution of queries without any interruption to the users, but also the performance SLAs must not change. One way to make sure that the user experience remains unchanged while you scale Presto up or down elastically in the cloud is to decouple Presto from the data management and caching layer. Now, what this does is that whenever you scale Presto down, you would not interrupt queries and you would also not impact the SLAs because the data management layer is decoupled from Presto. Now, this multi-tier caching strategy, which is implicit in this model, what this does is that while Presto remains tightly coupled with the data management layer, we get the best of both worlds, in which we optimize for performance, but we also optimize for cost by having these two decoupled from each other. The three key trends to observe are listed on this slide. The first one is data sharing and the need for an abstraction layer across different heterogeneous compute engines to maintain that your data pipeline flows smoothly. The second one is for data ownership and governance. Presto should be run across environments without making any data copies. And the last one is that for elasticity, a multi-tier strategy simplifies performance. Later on, you'll also hear from my team member, Bin, who's going to talk about further collaboration between the Presto and the Alluxio communities. Thank you and enjoy the rest of the conference.